Welcome to CSEGuru. In this session, we will discuss data structures and applications. In that, we are going to discuss about stack representation. So, what do you mean by stack? Stack is a LIFO data structure. What is the element you have pushed into the stack at last that will be removed from the stack first? So, only stack is LIFO data structure. There are two ways we can able to represent the stack. One is representation of stack using array. Another one is representation of stack using linked list. It is otherwise called linked stack representation. So first we will discuss array representation of stack. Stack is represented as a linear array in computer memory. What do you mean by array? Array is a data structure which stores homogeneous data elements in sequential memory location. That is, next to next memory location it will store. Okay, and the size of the array will vary from 0 to n minus 1. So here size is 5. Size of the total size of the array is 5. Totally 5 memory locations it will allocate. Starting location is 0 and last location is n minus 1. That is 5 minus 1, 4. Okay, so stack also we can able to represent like linear array. That is, the elements of the stack will be stored in sequential memory location in computer. And here every stack will have two variables. One is top, another one is max. So here top represents the address of the topmost element of the stack. And here only addition and deletion will happen. That is, the topmost position only. Elements will be added, or if you don't want, elements will be deleted. So insertion or deletion will happen at the top of the stack. And max, if we are considering in the sense, this represents the maximum size of the stack. As like an array, we will specify the size during declaration of array itself. Okay. So like array, in array representation of stack also, here we need to initialize the max variable. So max variable represents the maximum size of the stack. That is, what is the maximum number of elements the stack can hold. That is nothing but the max variable. If top is equal to null, in the sense stack is empty. There is no elements in the stack. So, if top value is null, in the sense no elements in the stack and stack is empty. Top is equal to max minus 1, in the sense max represents the maximum size of the stack and max minus 1 represents the last element of the stack. Suppose if top is max minus 1, in the sense meaning the stack is full. So, here if we are considering the array representation of stack, for example, here max size, that is the maximum size of the stack, initializing as 10. So here totally 10 memory locations. Starting location is 0 up to n minus 1. That is 10 minus 1, 9. And here once you have initialized the maximum size in the sense, this is the size allocated in computer memory. Okay. Suppose if top is equal to null. So top null, in the sense stack is empty. So here if we are considering, we have not inserted any element into the stack. Now stack is empty. So in this case, top value will be null. Top will be pointing here. That is minus 1 position, always it will point. Null, in the sense minus 1 we will represent. Okay. Suppose if I want to insert an element, increment the top position. This is the top position initially. Suppose if I want to insert an element into the stack, in the sense increment the top position. So if you are incrementing, now top will point to 0 position and place any element. For example, I am placing 50. Now, after inserting the first element, now this will point to the top. Suppose one more element, if I want to insert, in the sense, increment the top position by 1, 60. Next, increment the top position, 70, 80, 90. Likewise, I am inserting. Now, the top position will be pointing here. This is the topmost position. And here, still you can able to insert 5 more elements. Already we have inserted 5 elements. Still you can able to insert 5 more elements. Suppose if top reached the max position, that is here 100, 120, 150, 200, 250. Okay. So now top is pointing here. Okay. Suppose if you want to insert one more element, that is not possible. So when top is equal to max minus 1, this is nothing but max minus 1 position. So when top is equal to max minus 1, in the sense meaning the stack is full. We have allocated 10 memory location. All 10 memory locations we have utilized. That is the meaning. Okay. And when top is equal to minus 1, in the sense stack is empty. Okay. Top is equal to max minus 1, in the sense stack is full. Suppose here if you want to delete an element in array representation, the topmost element only will be deleted. This will be deleted. After deleting, top will point here. Okay. So always whenever we want to delete an element, the topmost element only will be deleted. So here element will be added or deleted at the top position. So if you want to add it in the sense, increment the top position by 1. Automatically pointer will goes to next memory location, place the element into the stack. Suppose if you want to delete an element, decrement the top position by 1. Automatically element will be deleted. Okay. So this is how insertion and deletion happens in array representation of stack. What is the drawback in array representation? Why we need to go for another representation, that is linked list representation? So the main drawback in array representation is size is fixed. What is the maximum size you are allocating? Only that size we can able to restore throughout the execution. Okay, you cannot able to increase the size further. That is not possible. So this is the major disadvantage in array representation of the stack. Suppose in case if the stack size is very small or the maximum size of the stack you know in advance, in that case you can go for array representation. That is, size of the array is not at all a problem in the sense, that is, size of the array you can able to judge. You can able to fix the size in the sense, in that case you can go for array representation. Okay. Suppose if the size of the array user doesn't know in advance or it is required to increase during execution, in that case you cannot able to go for array representation. Alternative representation is nothing but the linked representation of the stack. So to overcome the disadvantage of array representation, we can able to go for linked representation. Here size it is not required to fix. So whatever the elements we want to insert or push it into the stack, we can able to push it into the stack. Size is not a problem here in linked representation. So what do I mean by linked representation? In linked representation, every node has two parts. Already we know what is linked list. It has two parts. The first position will represent the data position and the second position will represent the address of the next element. First part will store the data, second part stores the address of the next node or next element. So this is actually the node structure. So every element in stack will have this node structure. Whenever we are pushing an element into the stack in the sense, automatically this node structure will be created, data will be placed here and that will be linked to the next element. Address of the next element, here we can able to link it. So this is nothing but linked list representation or otherwise called linked stack representation or simply linked representation of stack. And here the start pointer will be there for the linked list and that is used as the top. For example, the first element, if I want to insert here in the sense, this is the first element in the sense, here suppose element is 50, I have placed it. This is the first element I have pushed into the stack. Here no need to represent the address because next element will not be there. Okay, so this is the first element. So here this is null pointer and here this represents the top and this is nothing but the start actually. Initially this is nothing but the start. Suppose if I want to insert two more elements in the sense, here top position only you can able to insert. All insertions and deletions are done at the node pointed by top. So this is the top position. This is the first element in the sense. This only will represent the top position. And how the insertion will happen in the sense. So this is the top position. First element will be there. Okay. Next I want to insert 60 and 70 in the sense. Top position only. Here only insertion happens. So here node structure will be created and place the next element. Here you have to let. Now this will represent the top. Okay, suppose one more element if I want to insert, here I can able to insert 100. Okay, link. Now top will be represented by the newly added element. This is the top. So here all insertion and deletion. Suppose if I want to delete an element in the sense, here this element only will be deleted because stack is a LIFO data structure, last in first out data structure. So here only you have to delete the element. So all insertion and deletion are done at the node pointed by top. Insertion also will happens here only. If you want to insert, here only insertion happens. If you want to delete a top element only will be deleted. Suppose here top is null in the sense stack is empty. Okay, here maximum size it is not required. Okay, so whenever we want to add an element or push an element, create the node structure, add that element at the top position. And here, when top is equal to null in the sense, meaning the stack is empty, there is no more element in the stack. So this is nothing but linked representation of the stack. How many elements you want to insert, you can able to insert like this. See here, 120. Again, if I want to insert an element, here 150. Likewise, you can able to insert. And what is the new element you have added? That will be represented by top. That is the meaning. So this is nothing but linked stack representation or linked list representation of stack. So this is all about representation of stack using array and linked list. Thank you for watching this video.